Well, I just spent the last 10 minutes recording without my mic on, so let's redo it. Just gonna give you a general layout of some of the parts and what I'm expecting of them. So most of these 3D printed parts here are in PLA. In future iterations, I'm either going to use some Aero ASA or another type of lightweight material. This is more for testing. Weight's a slight concern, but I won't really know until I see it in action. A lot of this I'm going to reference in, I'll reference in the CAD so you can get a better idea. But this comes in 3 or 4 pieces. This would be the centerpiece. It's going to have 2 carbon fiber rods going through it. These are 14 millimeter by 12 millimeter, outside and inside, respectively. They're 1200 millimeters long, and so they should protrude into both wings substantially. And so a lot of this is just learning the process for assembly and any things I overlooked, you know, like little holes and pockets for wires to travel through. Sometimes when you're in CAD design, you can overlook those things. Here are the wings. There's the general profile of the airfoil. It is completely eyeballed. I just hopped on there and was like, yep, that looks like an airfoil to me. I just winged it. Get it? The rear is made up of 3 components. Center portion of the rear stabilizer, horizontal stabilizer portion. It will have one servo embedded that will be to actuate the elevator craft. It won't have a rudder for now. I will be using differential thrust. I don't think that'll be too difficult of an adaptation later. Yeah, 3 components. That's the center side. 2 outsides. They have got some dual vertical uprights there. As far as the landing gear and wheels, so yeah, I have some 11 millimeter outside, probably 10 millimeter inside, so about 1 millimeter thick carbon fiber rods, nice and strong, braced up in a nice triangle. Active braking setup using an O-Drive S1 as the motor driver and the brain of the motor. A small encoder magnet shaft connected to a drone motor. Right now this is just a 3D printed wheel on the hub. I'm experimenting with polyurethane, as you guys have seen in this video, and molding that. I'm running into some difficulties, but that's a whole topic on it in its own. And then some TPU flexible tires, or go with a simpler, you know, off-the-shelf electromagnetic braking wheel, because they are relatively cheap, probably sub $200 for a set for 2 in the front. Length of the aircraft will be supported by, I believe, 24 outside, 23 inside diameter, about this long. I let this length of this decide the length of the aircraft, so kind of started there. 2 of these guys to run the length of the aircraft. As you guys will see in the CAD, I have a lot of space along that body. If weight doesn't become a huge issue, I would like to utilize some of that for potentially parachute, like a recovery parachute, or cargo, so I can drop some cargo, carry some cargo. Who knows? Put anything on there. But again, that has to be seen. I made the rear stabilizer oversized to allow for that kind of adaptation later. If I decide to use the run of those booms, I wanted some more authority in the rear of the aircraft to kind of compensate for additional weight back there. This is the communication behind that whole, ideally. About 7 of these guys, I'll show you here, off of a little lot sale on eBay. Bid for like less than $100. I got 7, I already had 1. I can do one-way communication between my ground control station and the aircraft. And these are things that are supposed to do something like high 20-mile line of sight, perfect condition, telemetry range. And the whole idea behind the Raven system is to have kind of a mesh network between Raven 1, which is something else. I'm pretty sure, even though that vehicle precedes this one, it'll probably come out in a later video, because that one was more about the catapult design. Hopefully I'll be able to use like vehicles like that as a relay station. And later on we can incorporate things like the Auto Rover or the Albatross series of autonomous boats. All right, don't know what to expect here, but let's go ahead and start putting some stuff together. All right, confirmed. This time I am actually recording. Now, is that clearance? A little loose. I'll show you, oh, you can see that there, but a little loose. And then it's gonna go through some of the same thing, the same like little nipple on the front end here. But that's fine, because I'll be applying epoxy around the seam, and then I'll also just put a bunch of epoxy in there as well. So should give it some stability. Line these suckers up. Let's get in here. Let's get in there. Well, that was as sketchy as it looked. I know what you're thinking. That carbon fiber is split and frayed on the end. And you'd be right. Section together here. I'm wondering, should I throw some plumber's tape on there? Plumber's tape? What did I just say? My God, I meant painter's tape. All right. It's even more messy in here today. We are back now. I'll try not to breathe like Darth Vader in the mic, but overall, no guarantees. Nice. Might be able to kind of just piggyback off of these with the third one. Might have to, honestly. Oh wait, this isn't the piece that goes here either. Oh boy, yeah, we're really short. We're super short. It would take a few years to get there, and then you're talking like 2027, the asteroid would... That was a pretty large oversight. Distant Not oversight, just bad designing. This is the toll. And then this would go here. And then another section would go here. So I think I've missed the point. So what I think I'm gonna have to do, I'll double down, pull the dowels out this way, and then I'll have two new ones on that end, centered here. And then I can run some, because I think these are 12 millimeter inside diameter. I'll run some 12 outside, 10 inside carbon rods through those to keep them really, to provide structure in between both spars. So it's less like two independent sets that could flex in the middle. Much larger than 4 millimeters, Jesus. Okay. Look at that thing, dude. Check that out. Starting to look like something. All right, so it's all dried. This blue masking tape on the outside. There's also blue masking tape running in between the two. Wow, look at that. There's like no leaking. That is a huge improvement with this setup here where I put bolts all on the outside here. So let's see. Sorry guys, I know the lighting is absolute trash, but it does seem to solidify it a bit more. It's not really sucking up anymore there, and the dripping has ceased to drip. All right, see, something I didn't think about until once I was already pouring this is I have the two holes on the side to pour the resin into, and I really should probably just have one in the center to help reach the high point there in the wheel. The top of the mold here where the tire is kind of looped around. How is it going to get to that area? It might not. We're just going to have to see. Definitely quite stuck together. Yeah, it looks like it's just tearing again. Definitely an improvement on the mold itself. Yeah, this is a loss again. Look at that, completely separating. I'd like to get inside just to have a peek at what's going on. All right, total loss. All right, just wanted to show you guys kind of the airfoil layout. We have this routing here for all of my wires, my servo leads, as well as my phase wires for the motor, so they can run internally into the fuselage there, as well as, a few holes for the carbon fiber spars, and then some other holes for access to the servo, so I can remove it and adjust it, or clock it, I guess I should say. And this is just an unused one. I was going to put a little 4 millimeter dowel back there, but we're just going to work around that. Next iteration of these, I have this little detint or whatever from one part that goes into the other. That way, when it actuates here, it moves the whole aileron. When you separate this section of the airfoil, you're able to just pull it out. This was a bit tighter, so it's kind of stuck. I will make a better way to connect the different sections of the ailerons and the flaps in order to make them easier to detach here. I'm glad I seen that. Look at that. God dang it. Brand new servo. Torn wire there. I can fix that. I'm sure that happened. Pushing the carbon fiber rods through. You know what? It's a ground wire. We'll fix it. God dang it, man. Where the hell did that wire go? Oh, the servo must be hanging. Oh, for like fire department and stuff like that? I'm sorry? Can't really get into that actually. All right. Let's get the power supply rigged up, get some power to these two servos, and clock them. Here we are, guys. A few months later, the plane is coming together. Sorry for the mess. Right now I'm working on some active braking. Initially, we were going to use the O drives, but, you know, over complex for this build. This is just a prototype anyways, but I still do want ability to brake on the wheels. We have a few options. Could just buy off-the-shelf wheels with electromagnetic brakes, but, you know, that'd be too easy. So for now, we just have some brushless motors. I can't remember what they are. Some are like 1,000 kV or something. A little ridiculously fast and under torqued for this application, but it's fine. We're going to use a few of these just because they're lightweight. BL Heli ESCs, I've used these in the past, and I had a few in stock anyways. We're going to use that just to provide a reversing action on the wheels to give us some force, some braking force. It's not our end resolution. It is just our temporary fix, so we have some sort of braking for this beast.